Hello, everybody. Today we'll be starting our second big unit, which will be looking at electricity. So specifically, what is electricity? How is it made? How is it transported to your house? And also different methods of making it as well. So before we start talking about that, though, it's actually linked back to some of the stuff we saw in chemistry. So in chemistry, we looked briefly at what is the structure of an atom? What does an atom look like? And we found out that inside an atom, there were these protons and neutrons that were clumped together. And then on the outside, more loosely held, were these negative electrons. So just quickly fill in this chart. So protons, those were on the inside of an atom. We call it the nucleus, that inside clump. They were positives. The neutrons were also on the inside there. They had no charge. And then on the outside in these orbits were the electrons, and those electrons were negatively charged. So when we're talking about electricity, electricity is actually when you have these electrons flowing through a material. And because electrons are on the outside of an atom, it's easy to take them away from things and make them move between atoms and make them move down a wire, for example, which is just a bunch of maybe copper atoms all in a row. So it's really these electrons that are involved in electricity. So electricity, so what is it? It really just involves the movement of electrons. So when you turn on the light in your house, the reason it works is because electrons start flowing down the wire and through the light bulb, and that's what allows it to work. So electricity really is the movement of electrons. Now, only some materials allow electrons to move easily through them. And we call those materials conductors. So examples of some conductors would be copper, one of the most common ones. So power lines, the wires in your house, those are all made out of copper. Your phone charger, the wire that's in the wire of your phone charger, that's a copper wire. An even better conductor is gold. So there are small amounts of gold in your phone. The circuit board in your phone has small amounts of gold. Your phone needs electricity, it needs flowing electrons to move. Normally those electrons come from a battery, right? And then you charge that battery up. And those electrons flow even better through gold. So there are small amounts of gold on circuit boards like the one in your phone. Other conductors, even tap water. So if you fill up a bathtub with tap water, even that has some things dissolved in it. It's not pure water. It has some different elements and ions dissolved in it. So actually it can also conduct electricity, not as well as copper and gold, but it is still a conductor. So that also, that's also why you need to be careful about things like having a hairdryer near a bathtub. If that hairdryer falls into the bathtub, the electrons, the electricity could flow through the water because the water out of your tap is still a conductor. Conductors are used when you want electrons to flow. So for example, in power lines, if you want to get electricity to people's houses, you're going to use a conductor, and they use copper in power lines. In electronics, right, we talked about your phone already. Also in appliances, right, things like stoves, right, your fridge, your lights. There's other materials called insulators. So anything else we would call an insulator. So something like styrofoam. You couldn't create a circuit. You couldn't allow electrons to flow down a wire of styrofoam. So we call that an insulator, something that doesn't allow electrons to flow very easily. All right, so we're going to go through this little activity here. We're going to test out a couple materials and see if they are good conductors. Can you make electrons flow in them? Could you make a wire out of them and make a light bulb turn on? Or are they insulators? Do they not allow electrons to flow? All right, so we'll go through each one of these materials. All right, so here's the little simulation. Up top, I have all of my materials here that we're going to test out. And down here, we have our circuit. So we have a battery that's going to supply the flow of electrons. It's going to allow the electrons to move. And that battery is connected up to a light bulb. And then the wire goes around like this. Now, right now, the light bulb is not turned on. Why is that? And the reason is because this is not a complete path. It's not a complete circuit. The electrons can't flow from one end of the battery to the other because there's a big hole here. Air is not a conductor. Air is an insulator. Electricity will not easily flow through air. All right, what we're going to do is stick some different objects in here and see what happens. Okay, so first thing I'm going to take, so alloy, it's like a metal alloy. So this is some sort of metal wrench. And we're going to stick that into our circuit. We're going to connect it up to both sides. Okay, now the light bulb turns on. So that tells us, yes, metal is a conductor because electrons can flow along this path now. So now the electrons are going and they're flowing all the way through. Actually, they're going this direction. They're flowing all the way through. They're going through this piece of metal alloy, through the light bulb. That's what turns it on and back to the other end of the battery. And these electrons just keep flowing, and that's what turns it on. Okay, so in this case, the metal alloy is a conductor. It works. We can see that because the light turns on. All right, metal alloy is a conductor. You can make a circuit out of it. Next one, water. All right, let's take some perfectly pure water. This is called distilled water. We have some of this in the lab that we buy. It has nothing in it. It's different than your tap water. Okay, we put just perfectly distilled water. Nothing happens. Electrons don't flow, and that's because they can't go through the water. So perfectly distilled water, that's an insulator. You can't flow water through it. Let's try the next one. Now we have some salt water. This is more similar. I mean, obviously your tap doesn't have salt water, but your tap has other things dissolved in it. So it has other elements that are dissolved in it. It has some ions in it just naturally, right? It also has things like small amounts of chlorine and things like that to keep it safe to drink, to stop things from growing in it. So it does have small amounts of stuff in it. So it's more similar to the salt water. And in this case, okay, the light bulb turned on. That tells me, yes, electrons are flowing through this. The salt water allows them to go through it. So salt water is a conductor. You can make a circuit through salt water. All right, next one. Now we're going to stick a chunk of copper in there. And okay, I drop it in. Yep, definitely electricity can flow through copper. Copper is a good conductor. Electrons can flow through it. Now, that's not a surprise. These wires here, they're actually made out of copper already. They've put like a plastic sleeve on top of them just to protect them so they don't get damaged. But these wires are already copper. That one's not a surprise. Glass. All right, you can take a guess. We'll see what happens. No. So glass is an insulator. You can't make a circuit out of it. You can't make electrons flow down it. Glass is an insulator. All right, a wooden pencil. Take a guess. Nope. So if you put a piece of wood in there, does not allow electrons to flow. It is also an insulator. Can't make a circuit out of it. Graphite. So you take one of your clicky pencils and you take out the piece of graphite. Here's my piece of graphite. You can guess what's going to happen. My hint is you've seen this in one of our chemistry labs. Aha, it works. All right, so in this case, it is a conductor. You can flow electricity through a piece of graphite. Graphite is a conductor. Now, if you think back to the lab that we did when we split apart water, right? We were connecting up the battery, we put it into some sort of salt water, and we were seeing the bubbles, right? The hydrogen was forming on one piece and on one part of the wire, and then the oxygen was forming on the other part of the wire, and then we lit the hydrogen on fire. When we were doing that lab, on the end of each wire, we attached a little piece of graphite like this, right? And that's just because we needed something that was a conductor that would allow the electricity to go in and then flow to the other side through the water. So we actually saw in that lab that graphite was a conductor. All right, next one, piece of aluminum. You can take a guess here. Aluminum is a metal. So just like copper is a metal, yes, it conducts electricity. It's a conductor. Last one, plastic. Stick a plastic ruler in here. Nothing. Plastic's an insulator. You can't make a circuit out of it. So the main ideas from this lesson, electricity is just when you have flowing electrons, when you have electrons moving down a wire, down a material. And that can only happen when you have a material that's a conductor. Those are usually things like metals, right? Most common ones, copper.